Hello, welcome to the first Evolution Simulator video. This series was inspired by the work of carykh, who used evolution to create and optimize simulated creatures. The eventual goal of this series is to produce complex and diverse creatures through random processes. This video is an introduction into the systems that I will be developing, as well as a demonstration of what evolution looks like in a simulated system. Firstly, a brief introduction to the simulation. It exists on a hexagonal grid where every space has the potential to hold a tree. Each turn there is a certain probability that a tree will have a child on an adjacent space. And each tree only lives for a certain amount of turns before it dies. Let's put a tree on the grid and see what happens. As we can see, the grid is being filled up by children of the original tree. Notice how trees don't automatically spread to adjacent spaces? This is because there is also a chance that a space will remain empty when it has a tree next to it. However, the more trees surrounding a space, the more likely it is to be filled. On the right of the screen, there is a graph denoting the different types of trees in existence. Each tree has a fixed number of evolution points. This graph is based on the distribution of points within the population. At the moment, there are only two things a tree can spend its points on, though I plan on adding more in future. A tree can either increase its likelihood of reproduction or increase its lifespan. However, an increase in one quality means a decrease in another. Because each child differs slightly from its parent, survival of the fittest takes place, meaning only the most suitable candidates survive. Let's run a simulation for a longer time to see what happens. To make the trees evolve more quickly, I am running the program at 10 times speed. Each different type of tree has a slightly different color that corresponds to its distribution of points. The increasing amount of blue trees shows that the trees are using their points on reproduction rather than lifespan. However, the shift is gradual and takes hundreds of generations. You can also see the same shift when you look at the graph, which is gradually shifting to the right. It is clear from the normal distribution of the graph that there is a single dominant strategy, represented by the trees. Because I saw that the trees prefer a single strategy, I wondered if I could alter their environment to encourage multiple strategies. To do this, I will use a much larger graph and remove a grid-like pattern from the top half of the hexagon, meaning that it will act as a different environment. Let's let it run for a while. Unfortunately, it does not appear that the new environment altered the behavior of the plants. This is clear because the mean of the graph in this experiment is the same as the last experiment. In the next part, I will give the trees new abilities to try and alter how they react to their environments. Thanks for watching. I'd be really interested in hearing what you thought in the comments section below.